Gases. In this chapter, we will be discussing gases. Our first video will lay out the goals, what you must know to do this work, and a brief review of introductory terms. Our goals for this chapter will be to learn volume, pressure, temperature relationships. We're going to do this in both a qualitative and quantitative manner. Then we're going to use the ideal gas law to solve problems and treat mixtures of gases using Dalton's law. Finally, we'll relate the microscopic and the macroscopic together with kinetic molecular theory. And then finally, we'll learn how to do all of these things for non-ideal gases as well. As with most chemistry, this is dependent on how much of the material you've already learned. Make sure that you know how to do your conversion factors and dimensional analysis quickly and efficiently. There will be a lot in this section. Also remember all of your previous work on chemical equations, stoichiometry, and limiting reagents. When we get into mixtures of gases, this will become a very, very important part of doing the complex problems. Let's introduce some simple concepts now. We are going to convert between pressure units, or at least talk about how to do it. Then we'll talk about gas properties, and finally learn how atmospheric pressure is measured. Gases have several important features that make them different from liquids and solids. While similar to a liquid in several ways, such as having no defined shape and mixing amongst each other, it is very different in other ways. It has a much lower density and can be compressed. The reason for both of these is that the molecules are very far apart, rather than directly touching each other like in both liquids and solids. The molecules are moving, for the most part, freely. So the space between them is what allows for the compressibility. It also means that there are less atoms for a specific volume, which makes the density lower. When visualizing gases, we can simplify the atomic models that we've discussed in previous classes to rebounding balls. While it doesn't always work, it will be the basis of our work because it does so often. You can picture them as rebounding balls that fill in a container. There is space between them. This picture, or video, will help us in both our discussions, and we will be further expanding, defining, and explaining this concept as we continue into this chapter. While I'm not going to practice unit conversions with you, because they are the same as every other unit conversion, we should talk a bit about what they are. Let's start with the SI unit. A pressure is the force that something exerts over a given area. Think about if I asked you to put pressure against a wall. It would be the amount of force that you could exert through your hand, or whatever area you chose to make contact with. And putting this in terms of SI units, we have force, or a Newton, over area, or meters squared. As with most other measurements, there are several other units that are used. 1 atmosphere, as you might expect, is approximately the atmospheric pressure at sea level. 2 other units that we use are millimeters of mercury and torr. These are both effectively the same, but you'll see them written both ways. Now, let's look at where the measurements come from. It used to be that we measured atmospheric pressure by measuring how far the atmosphere was able to effectively push a column of mercury up a vacuum tube. A simplistic version of this is drawn to the right. The pressure from the atmosphere pushes the viscous liquid up a vacuum tube, fighting the pull of gravity that is pulling it down. At 1 atmosphere, the mercury would be about 760 millimeters high. And this is where the measurement of 1 atmosphere equals 760 millimeters of mercury comes from. In summary, we are going to be spending the next section discussing gases, a compressible, low-density phase of matter which takes the shape of its container. The molecules can be visualized as rebounding balls that collide with each other. This is a simplistic model that we will be expanding on. There are several units for gases, and while the SI unit is pascals, we most commonly are going to be using torr, millimeters of mercury, and most common of all, atmospheres.